right, Joris. Hey, thanks so much for joining us in the your own little private tour of Amsterdam in our nice little Audi. Can you tell us a little bit about who you are and what your background is?
Yeah, sure. Yeah, I'm Joris Cramwinckel. I work for Ortec Finance for over 10 years. Started just after graduation. And my personal life, I'm a father of 4 sons.
Oh, wow.
So I don't have time for hobbies.
Yeah, right. I only have 3, and you're now the second person I've interviewed that has had 4 kids. And I always feel like I have a lot with 3, but...
Yeah, our youngest are twins, so I'm cheating a bit.
Yeah. How old's your oldest?
9.
9, okay.
9, 8, and almost 3.
Yeah,
Twins.
Mine I think are a little bit easier now because mine are 20, 16, and 14. So they're pretty self-sufficient at this point.
Get some free time back. Yeah.
Exactly.
I just have to make sure I make fun at work. There's not much time left. Yeah.
Right.
And at work, I have a background in high performance computing. I actually graduated here in Amsterdam, but I didn't saw the city that much. So. Was mostly in the university.
Right.
And started different engineering roles at Ortec Finance. And what we do as a company is we design mathematical models to make better financial decisions.
Right.
And wrap that into software and ship that as SaaS solutions.
Oh, as SaaS solutions.
Yeah.
And so in your environment is like a big kind of Kubernetes and OpenShift?
Lately.
Yeah,
we're moving there. So I was responsible for setting that in motion, indeed. While our company, I think for the last 15 years, we acknowledge it's a 40-year-old, what you would now call Fintech, I think.
Yep.
And formerly it was shipping software made by econometricians for econometricians. So we had an R&D department specifically focusing on mathematics and econometrics. And 7 years ago, I convinced my boss, who's now CTO, that we should also research technology because the landscape was changing so fast. And every tier, right, on the front end, the back end, also database technologies. It was the era of the NoSQL.
Yep.
And I let myself a part-time position next to my engineering activities in the lab.
Try to look for what's next.
And then I became responsible for all new to the company tech. And we had a lot of cloud technologies, also given my HPC's interest, cloud technologies in our lab. I think our first Kubernetes experiments were in 2016, something like that. Playing around with serverless and with the cloud.
But you were doing serverless in 2016?
Yeah. Just after Lambda came out, I had to supervise. I also supervised students, master students, and one of the professors was saying, you should check out
this Lambda.
Lambda. And actually we did research on where is the break-even point back then to make it cost efficient. Because if your containers are utilizing or having a high CPU utilization, then it's cheaper to use regular container technologies.
Right.
And so that's one example, but we did many. And after, I think just prior to the COVID crisis, with the CTO office, we revised the whole enterprise technology strategy. And that was, for me, the opportunity to get all these technologies where we're in my lab for a while, into what I call the factory.
Yeah.
And so together with my colleagues, with the chapter leads, we wrote out this strategy. And cloud native.
And event driven as well? Because typically in fintech, right, a lot of stuff is, because I was a consultant for a long time. A bunch of that was in fintech or financial services. I actually did some work for Thomson, speaking of software as a service, about making good decisions. you know, a lot of those architectures have been enterprise service bus, you know, kind of event-driven architectures for a long time. Was your environment like that, or was it more kind of, you know, because in some ways modeling is more like a, you know, you put in the parameters, right, and out comes an answer.
So we have event-driven architectures at the moment, just because the cloud native stack allowed us to embrace these new paradigms more easier than in traditional ops. In our on-premise operations, these type of architectures are not supported. But in a nutshell, we build a lot of calculation engines indeed. And some of these engines are used by banks, large Dutch banks use our models from their mobile app. So,
interesting.
So then we forecast kind of the probability of reaching your investment goals if you're an individual investor, and then we need to cater for an answer, like an API, within 2 seconds. So that's number crunching, multi-threaded.
Well, and it's hard. It's even harder to do multi-threaded than typical, because you're trying to put all the calcs together, at some point. Which is adds another layer of complexity.
So that's more. Some people call it microservice. We call it microservice or services. We are not married with the term microservice.
I'm still it's a service-oriented architecture. It's the idea is it's services, whether they're big or small services. Do we? I mean, I think what I have liked about the microservice buzz term kind of has been kind of a push towards the Unix philosophy of this thing does one thing well, and the way you get stuff is by chaining together. So that's been a big help. But at the end of the day, it's still a service, right?
It's still a service. We also have in terms of doing stuff well, forecasting the balance sheet of a pension fund is a single responsibility thing, right? But you can imagine we have 600 lines of code that doing that. And these are our product ranges from web products with GUI, without GUI, with only API, but also more traditional desktop products. In the era of it's by econometricians for econometricians, you can imagine there are not thousands of users. And there's no business case to
kind of have that kind of scale.
To migrate thousands of screens in a desktop app. And there we do believe in thin client fat server. So
I also worked on trading desks. So
I know exactly what you mean. So all the compute part. Of course, we package that now in containers, and where we were first doing distributed computing on bare metal on self-managed data centers. Our enterprise technology strategy stated we do managed over do-it-yourself. So we stop maintaining data centers.
Interesting.
Well,
I mean, and I'm sure kind of containerization has also allowed a lot more of your kind of code reuse in different scenarios, right? Where you probably had a lot more custom thing, like one thing that worked for desktop and one thing that worked for, I don't know, mobile, right? And now with the containerization, you get a lot more usage, shared usage in a sense.
But what's fun is that you get these advantages where you don't expect them. So. For instance, now our CI/CD architecture is almost the same for Java Web as for the backend of desktop applications, and that's way easier to maintain. If everyone ships their stuff into container, as long as it's a container, all the management and the GitOps, all these we can standardize a lot of these stuff, not caring about what's inside.
Right.
And formerly we have branches in operations that do Microsoft technologies or do Java technologies.
Well, especially if you're like shipping to a desktop, right? Then that means you need every version of everything in your tool to be the same, and you need to make sure you don't conflict with local, which in a kind of a server scenario, it's a lot simpler, right? Because you can say, nope, just dedicate a VM that looks like this, and it's going to work this way. But with desktop applications, that's a whole nother nightmare, and it's not with those kinds of tools, it's not like you can have a real simplistic desktop application, because it needs to still perform, right? It needs to be able to utilize that all the processing power or whatever of that workstation.
Yeah, but not if it's a thin desktop and all the computing is done elsewhere, and that's where we're moving.
Yeah.
To.
Oh, okay. Yeah. It's funny. I think the thin client was like the hot thing, I don't know, 15, 20 years ago? A long time ago. And it just kind of never took, really. There were some scenarios where it worked, but, I think we're finally getting back to that because of mobile.
But the same holds for a lot of paradigms in computer science. I think you mentioned the event bus.
Right.
That's also, event-driven is also very popular now, and also very powerful. Done right.
And it's that one. It always cracks me up because I actually was doing event-driven architectures using COM on Windows 25 years ago because I'm old. But it's just funny how, we keep looping. And there's a great talk. I don't know if he's still doing it, but he used to do this talk at OSCON every year, which is basically like everything in computing was like invented by 1979. And then he just kind of goes through all the modern stuff, and he's like, this is just like the thing they did in the 60s. It's just really amusing.
But in all terrains also, in the database also, first we had to decouple compute from storage, and now we're bringing back the compute to the data.
Because you can't move the data fast. It's really interesting.
And then yesterday there was, I attended a few talks in the EdgeCon track, where they mentioned that we will start shipping more and more software to devices.
So I just moved into a new building on the campus, and I was actually giving a brief talk about kind of edge computing and what it is for the students, and part of my examples was like, in that building alone, so it's 16 floors, but still it has trash cans everywhere, but every single trash can has scales in it that you can get real-time data of the weight in that individual trash can. And one of the really cool things that Boston University has done with their contracts is that now if they hire a vendor to do, scales and trash cans, I don't know. BU has as part of their contract that they can have the data back and that data be public. So we're basically generating like data science, data sets for essentially students to work on based on our actual consumption. So it's really kind of neat. It's one of the things I've got to look into over the summer. Is like, okay, you told me this exists. How do I actually get it? Because there's often a big difference between there's a data set for that and actually having it on my laptop. So what do you think is, kind of from your perspective, what do you think is going to be the next kind of big change? Is it going to be kind of getting all those things to like a cloud native scenario? Is that really the next major point, or are you already looking at something else on the horizon that you think is going to impact your, approach to these problems that, Kubernetes or OpenShift or, these tool chains kind of help enable or help you think about?
Yeah, good question. I think first of all, from our context, we acknowledge that this transformation takes time. I think even Netflix took 6 or 7 years to go from on-prem to cloud. And what we see now is the technology is actually pretty easy. At some point, if you're certain
if you
maturity,
get far enough along,
you fought your battles, and sometimes it converges, and you see engineers becoming better every time in embracing new technologies, and platforms play a big role into broadcast these new technology to our engineers. But the biggest challenge now is to change the humans, like the organization aspect to these technology changes. I'm a strong believer of Conway's law, and that the systems you build reflect kind of the
organization behind it.
How you communicate as an organization.
Right.
And as a company, we have 4 different units.
And so you have 4 different pieces of software.
4 different pieces of software, but also catering 4 different markets. So these cultures, although we are headquartered in the Netherlands, and we do have a large international work base, but I see so many differences within the teams already.
Yeah.
Yeah, I don't.
And so how are you going about that? There was actually we did a talk in Detroit with Ford. Did a panel talking about their transformation, like the same kind of scenario of like, how do you bring your swath of programmers to the cloud native world?
But that's the onboarding part, but also in the running part, right? Like your delivery process changes, even the salespeople, the consultants, the whole workforce is affected one way or the other.
Oh, that's interesting. Yeah. And so what are you doing to try to teach them all of that? Are you doing big camps? Are you doing publications? How do you bring that information to them?
Yeah, so every time we onboard a new product line, we are hosting these college tours with tailored sessions for engineers, but also for the non-engineers. And what we have 8 product lines. We're now onboarding the 3rd one, and we're teaching way differently. Like each time
you learn how to do it better.
We improve, but also the content is different. We're now busy with onboarding a team that has a release cycle for configuration. Typically in the financial sector, you can't release fast always. If you ship a SaaS solution to a bank, you cannot do that twice a week.
Right.
You cannot. The bank is not equipped to do that, or most banks are not.
Yeah.
So what happens is you don't ship new code, you ship new configuration. More often, and that's way different dynamics. So we now implemented kind of the a GitOps stack, but people are not familiar with code.
Right.
But with
so you're also like having to train your customers as well about how to like work with your products as well.
Also, but also the consultants who were responsible for shipping the right environments.
It's so funny. I still remember. So way back in the day, I did a consulting project for Fidelity, who you're probably familiar with.
That's a client of ours.
The finance world is actually a pretty small world. But
curious what you consulted them.
With the project we worked on, we were looking for a way to basically kind of like change how authorization and authentication worked in the existing system. And we, budgeted for like a 3-month project or whatever to do this work. And when we were working on it, I kind of saw this way we could kind of slide it in. And so we were done in like a month. But we missed the release day by a day, 2 days or something.
Oh, really?
So Fidelity essentially paid us to stay on board for another month until the next release window because it was, because we would have disappeared into other projects, or whatever. And it was more valuable to them to, pay for us to be around than it was to risk that configuration update, right? Or that release update window. And I still think about that with, talking about, continuous integration, continuous deployment, and, where some organizations, I also worked like in pharmaceutical, where, if you make a mistake and you drop a transaction on the ground, it was $1 million fine. Under some conditions. So, there's some scenarios where you want the same quality of update and change and that kind of stuff, but you don't want the same pace. And I think you see that in finance, like I said, you see it in pharmaceuticals. So it's interesting that you're experiencing that and trying to figure out how to how do you integrate that with these kind of modern development methods.
And when it really comes to the surface is when you design your GitOps flow, because that's really fun. Actually, last week we did that with the team that's responsible for configuration. And then that's where the technology and the process come together, right? So then we thought, okay, how do you want it to work? And how does it go right now? And a lot of handshakes, a lot of handovers, which we now in the current realm we can automate.
Right.
And also with the GitOps, it's so powerful. You can program your policies. So if someone does an update in configuration, you can say, okay, someone who's not the author, who has this role in the AD group of the company, is allowed to merge this pull request. And also, if someone releases configuration, how do you interact with the engineers? Because they are responsible in the end for the total service that is shipped. So. That's a very nice. These are very nice whiteboard sessions. Where you kind of shape your both your technology and process in one.
Right. Yeah. I think I missed a turn, so I was just checking to see if I.
A small detour.
Yeah. So tour this little part of Amsterdam. It's. I think, as we are able to divorce a lot of the, kind of the operating environment from the application environment, using containers and Kubernetes and things like that. I think it's getting interesting about, we're moving more and more to almost like a graphical design of your systems, where you have to have kind of call outs and stuff, or okay, this happens in this kind of scenario, these kinds of privileges and stuff like that. I don't think we have the tooling anywhere near there, but it's really starting to feel more like, you're kind of writing a run book for your operating environment in this very, mostly YAML, that, and you kind of just say, okay, here's the run book. Oh, computers, now go follow the run book.
Luckily, I have a colleague in my team who's very visual minded. He always draws a lot of withdrawal.io or whatever Lucid Charge. You have many places you can make these processes tangible by just using icon sets, and these also come with Kubernetes icons, with your hyperscaler icons.
Oh, I'll have to try that.
We do that a lot, actually, because in the end, it's what you say, under the hood it's all YAMLs, and we sometimes say, how do you like them YAML? Because it's
a little throwback to where I live in Boston. Thank you. But I totally understand. So I mean, I do the same thing with a whiteboard and my students all the time, right? Where I'm like, okay, this is how these pieces fit together and those pieces fit together, and my drawing is terrible, as is my handwriting. So it's always this chicken scratch all over the whiteboard, and then half the time the students want to take a picture of it so they can remember it for later. I'm actually going to go to the next one. And I'm like, can you actually read this? Because I can barely read it. I wrote it. So it's. But that visual component, I think, is really important to a lot of these scenarios.
So a lot of stuff we do is about visioning the possible, and then tailor the processes and technologies.
Right. So let me just convince it that we're going to where I want to go. Oops. Walk there, I want to drive there. I think this will work. I think I make Google Maps very angry when I'm driving this, but
I'm not familiar with here.
Yeah, I'm starting to get the hang of it, but I'm still a little, yeah. So what we want to do is actually just kind of take a right here, and then there's an entrance into the parking lot.
Oh, nice.
Well, thank you so much for your time. I really appreciate you joining us for a little ride around Amsterdam. I hope you enjoyed yourself.
Yeah, it was fun.